We have physics inter second year board examination. So from 9 a.m. to 12 p.m. So all the best for your examinations. I'll just again lastly I will address you. Now today I'll give you some tips regarding tomorrow's second year final board examination, intermediate public examination, second year. I am Srinivasan, physics lecturer from Spark Academy. So students, second year IPE, intermediate public examination, physics. Second year physics, again weightage will start with VSAQ. Generally, you people, students will study first long answer questions, then group of short questions, and then very, very short questions. Today, I'll address you, if not all the questions, because I'll address you 2 hours. In 2 hours, whatever the probability of important questions are there, including problems, I will tell you. So generally, I'll start with very short questions. Then for half an hour or more than half an hour or 35 minutes or so. Then next, we'll address 35 to 40 minutes about short questions, last 40 minutes about long questions. Like that, we'll do. Very short questions, according to IP blueprint, we have from ray optics. Very short questions comes from ray optics. Then moving charges and magnetism. Moving charges and magnetism. Ray optics, moving charges and magnetism. Magnetism and matter. Magnetism and matter. Alternating circuit, AC circuit, alternating current, AC current, alternating current. Then EM waves, electromagnetic waves, electromagnetic waves. Then comes dual nature of radiation and matter, matter and radiation. And 7, semiconductor electronics, Then 8, communication system. How the questions are asked here? Ray optics weightage is 1 question. Moving charge and magnetism 1. Magnetism and matter 2. AC current 1. Electromagnetism 1. Dual nature 2. Semiconductors 1. Communication 1. So this is the weightage. 1 here. How many? 10 very short questions should be there. Very short question section A, 10. 11. 1 plus 1, 2, 2 plus 2, 4, 1, 5, 6, 2, 8, 1, 9, 10. So this is the thing. So first we'll start with ray optics. In that, what are the important main questions we are going to see to it. So these are the blueprint. So more weightage is there. This magnetism and matter, 2 very short questions is coming. Dual nature also, 2 very short questions. 2 into 2, 4, or 8. Okay, students. Then we are doing first ray optics. Ray optics, mainly they are asking a very important question. Define power of the lens. Define power of the lens. What is its SI unit? What is its SI unit? What is its SI unit? Okay, sir, define power of the lens. What is SI unit? So how power of the lens is defined? In EG definition, you write reciprocal of focal length. Focal length should be in meters. Focal length should be in meter. Reciprocal of focal length expressed in meters is called focal power. Or they have defined terms of tan delta also. So, but easiest definition is this one, reciprocal of focal length in meters. So, SI unit of power is diopter. SI unit of power is diopter. Diopter given by D. Diopter D. This is SI unit. So, if you take another question, very short question in ray optics, what is myopia? What is myopia? How it can be corrected? 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 So I am giving idea what is myopia. Myopia means short sight, nearsightedness. That means they will be able to see near objects clearly. They cannot be able to see far objects. Why means in case of myopia, it will form before retina. The image is formed before retina, those who are suffering from nearsightedness. Nearsightedness. So here, nearsightedness, myopia is they cannot see distant objects. They cannot see distant objects. So why? You can write the image is formed before retina in your eye. How to correct this? By using concave lens, by using external glasses. So generally people suffering from defects wear glasses. External glasses. So by using, why means eye lens in eye lens will be there, that power is changing. So that is not able to focus your rays on the retina. That's why you are using. By using concave lens, what is the negative power? Concave lens minus power. It can be corrected. The defect can be corrected. These two, myopia, actually short questions and long questions is myopia concept much will not come, but very short questions they are given myopia and hypermetropia. Hypermetropia is what? Long-sightedness. It means they can see distant objects clearly. Though that students generally will have hypermetropia. Hypermetropia, they can see distant objects clearly. They cannot see near objects. It will form beyond the retina. By using convex lens of suitable power, hypermetropia can be corrected. So I am using remaining, what are the questions? Here, what is dispersion? That they are asking very much. What is dispersion? Which color gets dispersed more or deviated more? This is also very important question. What is dispersion? You know from school classes, splitting of white light into seven colors. That is web jar. Violet, indigo, blue, green, yellow, orange, red, web jar. Splitting of white light into spin. How white light splits in seven colors? When passes through prism. When it passes through prism, it splits into seven colors due to refraction. Splitting of white light into seven colors is called dispersion. Okay, this definition. Which color is one mark for this? Which color gets more? Violet color gets more dispersed because violet color refractive index is more. Because refractive index of violet color is highest, refractive index of red color is least. Which is having more refractive index, that will get more deviated. We having more refractive index. This is called dispersion. There is a small problem on small angle prism. I'll do for you that small angle prism. There is a problem. Small angle prism. 1 second, students. Small angle prism. Small angle prism. Small angle prism.
Sir, okay, clear the
Right.
little clear.
Okay. Sir. Okay. A small angle prism. I'll do in next page, students. See the writing. Any problem with that? Small angle prism. Small angle prism. Small angle prism. Small angle means A should be less than 10 degrees. A is 4 degrees. Small angle prism. A is 4 degrees. Deviates a ray through deviates a ray through 2.48 degrees. 2.48 degrees. 2.48 degrees. Find the refractive index of prism. Find refractive index. Ri means refractive index of the prism. Small angle means A should be less than 10 degrees. What is the formula for this solution? What is the formula? Angle of deviation delta is given by refractive index n. Mu or n is the formula for small angle prism. Delta is equal to n minus 1 into A. What is delta? He has given 2.48. Refractive index we have to find out. A is how much? 4 degrees. 4 degrees. So n minus 1 will become 2.48 divided by 4. Then n minus 1 implies that n minus 1 will become 0.62. 0.62. Refractive index will become 1.62. There is no units for refractive index. N is refractive index. Some books will give you mu also. Mu or n refractive index. This is a very, very important problem which is going to come to the examination very much. Number of times asked here this problem. So this is EAPCET questions. Now I am going to next chapter. Moving charges and magnetism. Moving charges and magnetism. Moving charges and magnetism. Moving charges and magnetism. So what are the questions in moving charges and magnetism we are having? What is the principle of moving coil galvanometer? What is the principle of moving coil galvanometer? Moving coil galvanometer. What is the principle of moving coil galvanometer? Answer. Principle. What is the principle? A current carrying loop or coil kept in the magnetic field, uniform magnetic field, gets rotated due to torque. This is the principle of moving coil galvanometer. A current carrying coil kept in the uniform magnetic field, uniform magnetic field gets rotated due to the torque. This is the principle of moving coil galvanometer. A current carrying coil kept in the uniform magnetic field gets rotated due to torque. That is very, very important. Anyhow, Ampere's law he has given. Ampere's law and Biot-Savart law we are discussing in short questions. You read, state and explain Biot-Savart law, state and explain Ampere's law. These two are very important for short questions. At that time, we'll discuss. How can you convert galvanometer to ammeter? 1 second, students. Conversion of galvanometer to ammeter. Next question is, how do you distinguish between ammeter and voltmeter? Also, they are asking. Distinguish ammeter. Distinguish ammeter and voltmeter. Ammeter and voltmeter. So what is the distinction? Ammeter measures current, right? Form a tableau called ammeter, voltmeter. Ammeter, voltmeter. Ammeter, it measures current. It measures current. Ammeter measures current. Voltmeter measures potential difference. Voltmeter measures voltage or potential difference PD across any device. So current is in amperes. This is measured in amperes. This is measured in amperes. This is measured in volts. This is measured in potential difference measured in volts. These two easy. Next one you want to write how to convert galvanometer to ammeter. By connecting a small resistance in parallel, you can convert galvanometer to ammeter. Right. How to convert galvanometer to ammeter? By connecting a small resistance shunt. By connecting a small resistance in parallel shunt to the galvanometer, it becomes an ammeter. How to convert voltmeter? By connecting high resistance in series. By connecting high resistance in series to galvanometer, it becomes voltmeter. It becomes voltmeter. Okay, student, this is also a very important question. Then, how to convert? This is also there. How do you convert galvanometer to voltmeter? How do you convert? I'm writing next question. How do you convert? How do you convert? How do you convert galvanometer how do you convert galvanometer to voltmeter? So they may ask ammeter also. How do you convert galvanometer to ammeter? Answer: by connecting high resistance in series. By connecting high resistance in series to galvanometer. In series to galvanometer, it becomes voltmeter. It becomes voltmeter. Same if they ask ammeter, by connecting a small resistance in parallel, by connecting a small resistance in bracket shunt, by connecting a small resistance in parallel to galvanometer, it becomes ammeter. That is why ammeter resistance is low, voltmeter resistance is very high. So this is question. One more question, generally they'll ask, what is the importance of Electrostatics experiment? They also one of the very short question. Electrostatics experiment. What is Electrostatics experiment? Electrostatics is the important scientist who found out current carrying conductor has magnetic field around it. What is Electrostatics says that current carrying conductor has magnetic field around it. So the magnetic field around it is actually it is a straight conductor is a symmetrical conductor. So around it circular. 95 lanes are circular. That is experimentally proved also. So current means what? Flow of electrons. Current means flow of electrons. Electrons in motion produces magnetic field. Electrons in motion produces magnetic field. That is the discovery of Eiersted. That is also there. Very short questions orally I am telling. Some of the questions I am writing answers on the board. Some of them I am telling orally. Because you are not do preparation now, you might have started the preparation today. Because yesterday Saturday exam is over for you, maths to do. Sunday is there. So Monday first year physics is over. Tomorrow second year physics is there. So you got so much time to prepare. You are in preparation, under preparation. You know very well about this. Next chapter I am taking magnetism and matter. Next chapter I am taking magnetism and matter. In these two very short questions will come. Magnetism and matter. Magnetism and matter. In this, what questions are coming? Define dip or inclination. Define S magnetism. Dip, or it is also called inclination. Define dip or inclination. What is the definition? Definition of dip is the angle made by the resultant field, resultant Earth's magnetic field, resultant Earth's magnetic field with horizontal or Earth's magnetic north. Horizontal or you write horizontal enough actually. Or in brackets you can write Earth's magnetic north. Earth's magnetic north. It is measured in magnetic meridian. Angle made by the resultant Earth's magnetic field with horizontal or Earth's magnetic north is called dip. So I am writing formula also. If you can write formula, I can write tan delta is nothing but BV by BH. Tan delta is angle of dip. Delta is called angle of dip. BV is called vertical component of Earth's field. BH is called horizontal component of Earth's field. It will be like this. Needle will come like this. This is called BV. This is called BH. This is called your delta. This is called delta. This is called resultant field. This is called resultant field. Tan delta is called BB by BH. BB is called vertical component of Earth's field. BH is called horizontal component of Earth's field. This is the definition of dip. Very, very important question. Now, define magnetic declination. Define magnetic declination. Magnetic declination is also important. Answer. The angle between geographic meridian and magnetic meridian at a given place is called declination. Inclination is different, declination is different. Inclination means dip. Declination is declination. Only one name is there. Magnetic declination or declination. There are two meridians are there. Earth's geographic north, geographic south. The plane containing geographic north and geographic vertical plane. The plane containing geographic north and geographic south is called geographic meridian. The vertical plane containing magnetic north and Earth's magnetic north and Earth's magnetic south is called magnetic meridian. There is some angle is there between geographic meridian and magnetic meridian. at a given place. It varies from place to place. It has got some value at Hyderabad, some value at Delhi, some value at polar region, some value at equator region. So like that in inclination also, different places, different values are there. So declination is different at different places, varies from place to place. This is another question. This is another question. Now, next question. Why magnetic lines of force are closed loops? Why magnetic lines of force are closed loops? Closed loops. This is one question. Why magnetic lines of force are closed loops? Why? This is another question. So answer, magnetic, for a magnet, lines of force externally travel for a magnet, line, magnetic lines of force externally travel from north to south, north pole to south pole, north to south means north direction, north pole to south pole, and inside the magnet, and internally travel from south pole to north pole, So magnetic lines of force are closed loops. Magnetic lines of force, magnetic monopoles will not exist, because if you cut the magnet to any level, they will be always in pairs, north and south poles. So in electric charges, positive charge can be separated, negative charge can be separated. So they can be open curves. In case of electric charges, positive charge separate, negative charge separate, they will have open curves in case of electric lines of force. But magnetic lines of force are always closed loops. Why means externally they travel from north to south, inside south to north they will travel. They are closed loops only because magnetic monopoles cannot exist. That is given by Gauss law in magnetism. Now, next, still anything they can ask in this. State Gauss law in magnetism. What is Gauss law? Because in this they will ask two very short questions. You should be very careful. You should read all the questions in this chapter. Gauss law in magnetism. What is Gauss law in magnetism? Answer, flux enclosed by closed surface is 0. Flux enclosed by closed surface is 0. That is Gauss law in magnetism. Flux nothing but integral B dot ds, that will be equal to 0, because magnet north and south poles will be there. For a dipole, flux will be 0. For a dipole, magnet is a dipole. Dipole means two equal and opposite poles. North pole and south pole will have equal and opposite strengths. That is called Gauss law in magnetism. Flux enclosed by closed surface is 0. In closed surface, we will have magnetic dipoles. Therefore, integral B dot ds is nothing but equal to 0. This is Gauss law in magnetism. What are the units of magnetic moment and magnetic induction and magnetic field? This is a very important question. What are the units of magnetic moment? Magnetic moment means M. Magnetic moment M. Magnetic induction B. Magnetic field H. What are the units of MBH? What are the units of MBH? What is M? Magnetic moment. SI units. What are the SI units? Magnetic moment, SI unit. SI unit is ampere meter square. Ampere into meter square. Ampere hyphen means into. Magnetic induction, SI unit is Tesla. Tesla T or Weber per meter square. H, intensity of magnetic field, SI unit, ampere by meter, ampere by meter. These are the units. MBH is a very important question. Okay. Now we are going to one more question they are asking in this. One second. There are some group of substances which are diamagnetic. They are asking like that. I don't remember the question, but you go through it. That question is they have arranged something: cobalt, bismuth, oxygen, nickel. Okay, nickel, chromium, so like that, chromium, gold, etc. like this. That's one substances. Categorize the substances into ferro, para, dia. Now I am writing what are ferro in this out of this. Ferromagnetic. What are ferromagnetic? So like this question is there, you please search in the textbook. Ferromagnetic are, what are ferromagnetic? Cobalt and nickel. Cobalt, nickel. These are ferromagnetic. What is paramagnetic? What is paramagnetic? I'm writing paramagnetic. Ferromagnetic, paramagnetic. Paramagnetic, oxygen, chromium. Oxygen, chromium. Diamagnetic. Diamagnetic. What are diamagnetic? Bismuth, gold. Diamagnetic. Bismuth, gold, diamagnetic. So you have to categorize substance. Some examples you have to remember and categorize. They are giving some substances, they will give you name which are ferromagnetic, paramagnetic, diamagnetic. Okay, students, this is another important question. Now, alternating current. I am doing alternating current, AC current. In this, what are very important questions? Alternating current. There is a problem asked in the alternating current. What is that problem? A transformer converts 200 volts AC alternating current to 2000 volts AC. 200 volts AC to 2000 volts AC. Calculate the number of turns in the secondary. Calculate number of turns in secondary coil. Secondary, if primary has 10 turns. If primary has 10 turns. They are asking in AC generally 50-50. Either problem or theory they are asking. So solution, transformer is a device working on mutual induction. There are two coils, primary coil and secondary coil. What is the relation between voltages? Voltage in primary by voltage in secondary is nothing but number of turns in primary by number of turns in secondary. This is the formula. What is the formula? Voltage in primary, AC voltage, primary by voltage in secondary is equal to NP by NS. What is converts 200 volt AC to 2000 volts AC? Primary voltage is 200, secondary voltage is 2000. Number of turns in primary 10 is given, number of turns in secondary we want. So this goes here 10 times here. So therefore Number of turns in secondary will become 100. Number of turns in secondary will become 100. Again, you see the formula Vp by Vs is equal to Np by Ns, or Vs by Vp is equal to Ns by Np. 200 by 2000, that is here 1 time 1 by 10 is equal to 10 by Ns. Ns is equal to 100 turns in secondary. Then other important questions in this is, what is the phenomenon involved in transformer? What is the phenomenon involved in transformer? Phenomenon or principle used in transformer. Principle used in transformer. That is, just now I told mutual induction. What is the principle? Mutual induction. Principle is mutual induction. There are two coils, primary and secondary coil. Between the flux is linked. From primary to secondary, flux is linked. The two coils are there. Mutual induction. There are two types of coils, primary and secondary. That also you can write. Which type of transformer is used in 6 volts bed lamp? Which type of transformer used in 6 volts bed lamp? You are using step down transformer. There are two types of transformer, step up and step down. What is step up? You are increasing AC voltage means step up. You are decreasing AC voltage means step down. In bed lamp, house bed lamp, which type of transformer is used is step down transformer is used. Orally I told you. So these are the questions, but still I am telling you what is the reactance of inductor. Please remember formula. Sometimes they lost suddenly this type of question. Reactance of inductor XL is nothing but omega L. Reactance of inductor, ohms. Omega means what? Frequency. 2 pi, frequency L. Reactance of capacitor. Reactance of capacitor. What is reactance of capacitor? Xc is nothing but 1 by omega c. 1 by omega c. So omega means 1 by 2 pi f c. So this is the alternating current questions. Alternating current questions. Then I am telling about electromagnetic waves. Electromagnetic waves. Electromagnetic waves. In this one more question will come. What is the relation between amplitudes of electric and magnetic fields in free space for an electromagnetic wave? What is the relation between electric field and magnetic field for a EM wave, for electromagnetic wave, EM wave? EM waves are transverse in nature. Answer is velocity of light c is nothing but equal to E by B. C is nothing but E by B. What is C? Velocity of light. C is nothing but velocity of light in air or vacuum. Velocity of light in air or in air. Velocity of light in air or vacuum. C is equal to E by B. So electromagnetic waves are basically transverse in nature. Basically, what is the principle of production of electromagnetic waves? What is the principle of EM waves? What is the principle of EM waves? EM means electromagnetic waves. Answer: time varying. What is the principle? Oscillating charge or accelerating charge. Oscillating charge produces time varying electric field, and magnetic field. Time varying electric field and time varying magnetic field. This is known as EM wave. This is known as EM wave. This is known as EM, electromagnetic wave. EM means you are right fully in student. Should not write short form, electromagnetic wave. Electric and magnetic fields are perpendicular to each other and perpendicular to the propagation also. Propagation direction, x direction is there, electric field in y direction, magnetic field in z direction. So what is the In electromagnetism, they will ask theory questions like this. What is the principle of radar? Microwaves are used in radar. Microwaves are used in radars. Microwaves are used in radars. Radar. Why microwaves are having high wavelength, short frequency? Microwaves are having, what is the answer? They have short frequency. They have short frequency and high wavelength. High wavelength. Hence, they are used in radar. Radar means radio detection and ranging. Radar means radio communication. They should have high wavelengths. They have short frequency and high wavelength. So, hence they are used in radar. Hence, they are used in radar. Still, is a thing. What are the uses of infrared rays? Infrared rays are used in remote, whatever remote is there, TV remote and all that. Infrared rays can travel to a long distance through fog and mist. So infrared rays are used. So heating treatment is there. Infrared rays are used to do for heat treatment because infrared rays are heat rays. Infrared rays for heat treatment to paralysis and all they use. Long distance photography they are using. They are using in remote sensing. They are using remote sensor, remotes. They are using electronics. They are used infrared rays. So please read ultraviolet rays uses, infrared rays uses, generally ultraviolet rays uses, infrared rays uses, X-rays uses. X-rays uses, you know, they are used in crystallography. They are used to detect fracture of bones and all that. So X-rays are used. So like this, the uses, generally electromagnetic uses of infrared rays, X-rays, microwaves, they are going to use. Microwaves uses. So microwave ovens are there. Microwaves are used. But I gave a question, microwaves, why they are used in radar? That is different. Where microwaves are used means, microwaves are used in Klystrons, some devices are there. Otherwise, you can use microwaves in microwave ovens. They buy in market microwave ovens that they use. So this is electromagnetic waves. So next chapter is, after electromagnetic waves, we are using dual nature of radiation and matter. So in this, what are important questions? What are cathode rays? So I have seen some questionnaire. What are cathode rays? Cathode rays travel from surface of cathode to anode, normal to the cathode. Cathode rays contain negatively charged particles called electron. I am telling orally what are cathode rays. Cathode rays are generated at low pressures and high voltages. Cathode rays are generated in a discharge tube at low pressures like 0.01 millimeters pressure and high voltage like 10,000 volts. So they found some invisible radiations are traveling from cathode to anode. They are called cathode rays. Cathode rays consists of negatively charged particles called electrons. Electrons are fundamental particles. Cathode rays contain negatively charged particles called electrons. Right? So any important 2 points you write, definitely they are going to allot marks. Cathode rays. What are cathode rays? Then what is photoelectric effect? Definition. What is photoelectric equation? What is photoelectric effect? What is photoelectric effect? You learned in chemistry and physics. What is photoelectric effect? When light of sufficient energy falls on metals, light of sufficient energy falls on metals, electrons are liberated. This is instantaneous process. Electrons are liberated. There is no time gap actually. Liberated whenever photon falls and the electron is liberated immediately. This is called photoelectric effect. This current is called photocurrent. This current is called photocurrent, photoelectric current. Photo means light. Photoelectric current. This is called photoelectric effect. Okay, students, what is photoelectric equation? What is Einstein photoelectric equation? Einstein photoelectric equation. Explain Einstein photoelectric equation. What is the equation? You write equation only. Kinetic energy maximum, left side you will write, is nothing but equal to incident energy like E minus work function. What is E? Kinetic energy means half mv square mag. E means h nu, incident energy, or hc by lambda. Phi naught is called work function. Phi naught is called work function. Work function. What is work function? That is also one definition. AP and Telangana, they are asking what is work function. Minimum energy required to remove an electron from surface of the metal is called work function. What is work function? Minimum energy required to remove an electron from surface of the metal is called work function. So what is E? Incident energy. H means Planck's constant. Nu means frequency of light. Nu means frequency of light. Lambda is wavelength. This is Einstein photoelectric equation. Okay. So you have to explain left side kinetic energy maximum, half mv square maximum. Right side E minus work function. What is E? Incident energy, light energy. Phi naught means work function. Definition of work function is what? The minimum energy required to remove an electron from surface of the metal is called work function. Work function varies from metal to metal. For sodium metal, some work function will be there. Some alkaline earth metal, some other work function will be there. Now, what is de Broglie's equation? What is de Broglie's equation? De Broglie equation. What is de Broglie? In this also two very short questions they are asking. We should be very careful. What is de Broglie equation? De Broglie equation, chemistry also learning. Lambda is nothing but equal to h by p. Lambda is equal to h by, lambda means wavelength. Explain each one every letter. Lambda is wavelength, h is Planck's constant, p is momentum. P is called momentum. Momentum of the particle. Momentum means mv, mass into velocity. M means mass, v into velocity. H means Planck's constant. H means what? Planck's constant. Planck's constant. So this is called de Broglie's equation. This is called de Broglie equation. They are asking often what is de Broglie equation. Heisenberg's uncertainty. They are asking Heisenberg's uncertainty also. Heisenberg uncertainty. Heisenberg's uncertainty principle. Heisenberg, what is Heisenberg uncertainty principle? Position and momentum cannot be at a time, can be determined. Delta x, there is a, if you detect position, you cannot exactly find momentum. Delta x in delta p is equal to h by 2 pi, h cross or h by 2 pi. This is called, delta x means change in position. Delta x means change in position. Delta p means change in momentum. Delta p means change in momentum. This is called Heisenberg's uncertainty. These are the main very important questions in real nature. Lastly, we are having semiconductors. Semiconductor electronics. Semiconductor electronics. In this, we are tell about very short questions. What are the majority carriers in p-type semiconductor? What are the majority carriers in p-type semiconductor? In p-type semiconductor, or sometimes n-type also they will ask. If I am writing majority carriers in p-type semiconductor, answer is holes. Holes. Vacant bond, vacant site in bond, holes. If they ask minority carriers, majority carriers are holes. Minority carriers are electrons. Majority carriers are holes. Minority, if they ask, in this they are not asked. They ask both majority and minority. Minority carriers are electrons. How you get p type? By doping trivalent impurity atom to semiconducting crystal, intrinsic semiconducting crystal like silicon or germanium, by doping trivalent. Valence is 3, that is 13th group. Aluminum, gallium, like that. We are getting p type. Same, they are asking n type also. What are the majority carriers in n type semiconductor? What are the majority carriers? What are the majority carriers in n type semiconductor? Electrons. What are the majority carriers in n type semiconductor? Electrons. Minority carriers are holes. How n type semiconductor can be prepared? By doping pentavalent impurity atoms to silicon crystal or germanium crystal, it becomes n type. This is first question. Then next. What is circuit symbols for? What is circuit symbols for PNP and NPN transistor? PNP and NPN transistor. NPN transistor. They are asking transistor symbol. What is the circuit symbols for PNP and NPN? Answer, I am giving you first PNP. Draw circle like this. Arrow inside. This is called base. This is called collector. This is called emitter. E is called emitter, C is called collector, B is called base. This is called PNP. Small letters also you can write. Small p, small n, small p also. This is PNP transistor. What is NPN transistor? What is NPN transistor? Arrow will be outside. This is emitter. This is collector. This is base. This is called NPN. This is PNP means arrow inside, arrow outside. Emitter, this is emitter. Emitter always, wherever arrow is there, that is called emitter. Collector, this is called base. These circuit symbols for PNP and NPN transistors. Okay, students, what are universal gates? What are universal gates? What are universal gates? Universal gates. NAND and NOR gates. Answer. NAND gate, NAND gate, NAND gate and NOR gate. NAND gate, NOR gate are universal gates. Are universal gates. Universal gates. Why they are called universal gates? Because by using two NAND gates you can construct AND gate. By using two NOR gates we construct once again OR gate. So please see that only NAND gate and NOR gates are universal gates, but not OR or AND or not. NAND gate, NOR gates are universal gates because by using two NAND gates we can get AND gate. By using two NOR gates we can get OR gate. So they are called universal gates. Regarding in any other question is there, we'll see first in this semiconductors. Right. Now, I am telling you communication system. I am telling you communication system. Communication system. Last chapter, communication system. Communication system, only one more question, one very short question will come. This is theory here. What is communication system? Define modulation. Define modulation. Define modulation. Why it is necessary? Define modulation. Why it is necessary? So what is modulation and why it is necessary? To modulation is necessary. Modulation is necessary to carry is necessary to carry weak signals to long distance by attaching high frequency carrier carrier signal to it, otherwise it cannot travel. So low frequencies cannot travel long distance, they die. Modulation is necessary to carry weak signal to long distance by attaching a high frequency carrier signal to it. So this is called modulation. Why it is necessary? Because if you attach high frequency signal only, you can travel to long distance. There you decode it and remove high frequency carrier signal, and you will see modulating frequency only. This is called modulation. And then what type of communication is used in mobile phones? Mobile phones, what type of communication? There are three types of communication is there. One is ground wave, another is sky wave, another is space wave. So to carry these mobile phones, we are using what type of space wave communication is there. Space wave communication is there in mobile phones. So what is sky wave also they are asking? What is sky wave? What is sky wave? What is sky wave? Sky wave, because ionosphere there are different regions are there, layers are there, ionosphere regions are there. So what will happen? You transmitter take a signal middle frequency regions, it gets reflected, and receiver antenna it will go on. So here, so sky wave, whenever a radiating signal goes, it goes into atmosphere ionosphere region in the middle layers. It go upper layers. There, what will happen? A molecular intensity and molecules available and intensity of sunlight available is they are medium. One is high, another is medium. That's why we are using sky wave in the middle regions. Middle regions means molecular concentration and intensity is average. So our signal will go, radiating signal will go, radio wave will go and gets reflected from the middle regions of ionosphere regions and gets reflected and reach the transmitter. So this is called sky wave. You read definition, right? Not many sentences, 2 sentences like that. How sky wave is going into the ionosphere and getting reflected. So that is sky wave. That is also they are asking some percentage of chance is there getting sky wave. What are the basic methods of modulation? What are the basic methods of modulation? One is amplitude modulation, another is frequency modulation, another is phase modulation. There are 3 types of modulation: amplitude modulation, frequency modulation, and third is phase modulation is there. Now, what are the parts of the basic building blocks of our communication system? Communication system basic building blocks. What is basic building blocks? What is basic building blocks of communication system? The chapter itself name is communication system. Communication system. How communication can be done? What are the parts? One is transmitter, antenna, Another is medium, that is cable or atmosphere. Third, again receiver antenna, transmitter antenna, medium means cable. So some noise will come in medium, that should be eliminated. So this is one. Speech signal frequency range also you see to it. This is the end of the very short questions. And one very short question I want to discuss, which I have not discussed in the radiation and matter, that is, there is a formula energy of photon hc by lambda. If lambda is doubled, this question is very important. I forgot, I am getting in memory now. Is hc by lambda. If lambda is doubled, what happens to energy? If lambda is doubled, what happens to energy? what happens to energy? E is energy. So lambda doubled means energy will become half. Lambda energy is inversely answer. I'm telling you what is the answer. Energy is inversely proportional to lambda. If lambda is doubled, energy becomes half. Energy becomes half. So you write like this answer, it is enough. E1 by E2 is equal to lambda 2 by lambda 1, like that. These are the very, I think almost I discussed 75% to do very short questions to you. Now we are going to short questions. Important short questions. Short questions will appear from which chapters? I'll just tell you short questions chapters what are. Short questions appear from chapters ray optics, second wave optics or physical optics, charges and fields, potential and capacitor, electric potential and capacitor, moving charge and magnetism, moving charges. Some are common to very short questions. Moving charges and magnetism. Chapters names I'm writing fast. As you can make out ray optics, wave optics, charges and fields, potential and capacitor, moving charges and magnetism, electromagnetic induction, electromagnetic induction, 7 atoms, 8 semiconductors. 8 from these 8 chapters, 8 questions will come. 8 chapters, 8 questions are there. Ray optics 1 question, wave optics 1 question, charge and fields 1 question, potential and capacitor 1 question, moving charge and magnetism 1 question, electromagnetic induction 1 question, atoms 1 question, semiconductors 1 question. So we can't avoid 8. Of course, there is choices there. Out of 8, you have to answer only 6. But in each chapter 1, at least 1 or 2 questions we have discussed now. So that is, first we are taking ray optics. In this, 2 important questions we'll discuss. Define, they are asking often 50%, more than 50%. Define critical angle and total internal reflection. Explain with diagram. Explain with a neat diagram, label diagram like that. Explain with diagram. This is very, very important question. Critical angle will come in the chapter ray optics refraction. It is concerned to refraction. There are 2 important concepts in light. One is reflection, another is refraction in ray optics. Refraction. So what is the definition of critical angle first? We'll do in critical angle. What is critical angle? What is the condition for taking for the critical angle? The ray should pass from if light ray travels from optically denser medium, to optically rarer medium or denser to rarer medium, you write. If you can't remember like that, light ray travels from denser medium to rarer medium, the angle of incidence for which angle of refraction is 90 degrees is known as critical angle. Critical angle is given by the letter C. So if light ray travels from optically denser medium to, you know the question, no? If you don't see the question also, no problem. See the definition. Light ray travels from optically denser medium to optically rarer medium. Optically denser medium to optically rarer. Optically rarer medium. The angle of incidence for which the angle of refraction is 90 degrees is known as critical angle. What is the diagram for this? I am drawing now. This is normal. This is called denser medium. This is called rarer medium, like air. This is normal. So light ray entering certain angle. If light ray is not going out, light ray grazing like this. This is called critical angle. I is equal to C. Angle of refraction is 90 degrees. Angle of refraction is 90 degrees. I is equal to C. This is called critical angle. Denser to rarer. Light ray travel from glass to air. Critical angle. Critical angle means if less than critical angle, ray will go out. Equal to critical angle, ray will just graze. This is called surface of separation. AB is called surface of separation, graze. Touch this line. This is called critical angle. Next page I will tell about total internal reflection. Total internal reflection. Total internal reflection. Total internal reflection. So what are the conditions for this? Conditions I am writing. Light ray should travel from denser medium to optically denser. Denser medium to rarer medium. Optically denser. You are right. Optically denser medium to rarer medium. This is compulsory. Correctly you are right. Rarer medium. Denser medium to rarer medium. Light ray should travel from denser medium to rarer medium, and the angle of incidence I should be greater than critical angle. What is C? Critical angle. I should be greater than critical angle. Then what will happen? The ray will reflect back to same medium. The ray will reflect to denser medium. This is known as total internal reflection. What is the diagram here? This is the diagram. Now we are drawing the ray like this. With normal, this angle is greater than critical angle, the ray will reflect back to same medium. This is called normal. This is called normal. The ray reflects back to same medium. Ray will reflect back to same medium. I is greater than critical angle. This angle is, let us say, theta. This angle is also theta. I is greater than C. This is called incident ray. This is called reflected ray. This is called denser. You write please in the diagram also. This is denser medium. This is nothing but rarer medium. Denser medium, rarer medium. Light ray, this angle should be greater than critical angle. Then ray will reflect back to denser medium. There is no refraction here. There is no refraction. This principle is used in mirages. That is also one of the important questions you can read yourself in the house. What is the explain mirage? Explain mirage, which is application of total internal reflection. That is important. So another important question in ray optics we are doing is about simple microscope, for example. I am talking about simple microscope. Simple microscope. This is an optical instrument. Simple microscope. Simple microscope. Another important short question. Ray diagram. It consists of one convex lens of shorter focal length. Okay. Object is kept within the focal length. This is focus. Object is kept within the focal length. AB object. Ray diagram. It passes through focus, another thing, goes through optic center like this. Okay. If we extend back these rays, they'll meet. So our diagram is not very good. The diagram is like this. High G. So simple microscope. Here I is kept. Simple microscope consists of a convex lens of shorter focal length. This is called magnifying glass. Object distance should be less than focal length. So object is kept object is kept within the focal length, within the focal length, within the focal length. That means object distance u is less than f. The image formed, AB is object here. What is object here? AB is object. The image formed is virtual. The image formed is virtual, erect, magnified. Virtual, erect, magnified. What type of image is formed? Virtual, erect, and magnified. Virtual, erect, and magnified. The image formed is virtual, erect, and magnified. I will bring down this diagram to you. So I didn't draw very properly, student. You have take a scale, same line you have to draw and make it extend it. It consists of a convex length of shorter focal length. Object is kept within the focal length, or equal to focal length, or less than focal length. Image formed is virtual, erect, and magnified. I is kept here. I is the image. AB is the object. I is the image here. Here, what is the formula for magnifying power? 1 plus d by f, near point. 1 plus d by f. D means 25 centimeters. F is focal length. This is the formula. Simple microscope. Simple microscope. Ray optics questions. So, any other questions are there in ray optics? Mainly concentrate on this simple microscope and this. 1 second. One minute, student. Simple microscope, I did, student. Critical angle quadrant reflection, I did. Rainbow also they are asking. Explain the formation of rainbow. Explain the formation of rainbow. Mainly they are asking critical angle quadrant reflection more than 50%. Another is simple microscope, formation of rainbow. These are the questions in ray optics. I am going to physical optics now. I am going to wave optics. In wave optics, they are asking important question. What is red shift and blue shift? What is Doppler effect in light? What is, this is not Doppler effect in sound. Doppler effect in light. Explain red shift and blue shift. Explain red shift and blue shift. Red shift and blue shift. This is very important. Distinguish red shift and blue shift. What is Doppler effect? Answer. Definition. The apparent change in the wavelength, change in wavelength or frequency when source of light like star, bracket star, approaching and receding the observer. Stars are light receding means moving away. Receding or approaching an observer on the ground. approaching an observer, stationary observer on ground. This is called Doppler effect. What is Doppler effect? Apparent change in the wavelength or frequency when source of light star receding or approaching. Receding means going away, or approaching away an observer on the ground. Observer is at rest on the ground. This is called Doppler effect in light. This is 1 mark. What is redshift? I am writing. What is redshift? I am writing. What is redshift? What is redshift? Then you will get redshift. When star moves away from the observer, moves away from observer at rest on the ground, at rest, moves away from observer, color of star changes to red as wavelength increases. As wavelength, I am writing lambda. You write in examination wavelength word. Lambda increases. As lambda increases. When the star moves away from the observer, color of star changes to red as lambda increases. What is blue shift? What is blue shift? When star moves towards an observer at rest, wavelength decreases. Wavelength increases means frequency decreases. Wavelength decreases and color of the star changes to blue. This is called blue shift. That is called red shift. Wavelength is increasing. You can write formula delta lambda by lambda is equal to plus or minus V by C. Delta lambda by lambda is equal to delta lambda shift in wavelength, lambda original wavelength. V is velocity of the star, C is velocity of light. C is velocity. This is most 50%, more than 50% they are asking in wave optics this. Then is law of conservation of energy is valid for interference and diffraction. Is law of conservation of energy is valid for interference and diffraction. How will you explain? Is law of conservation of energy is valid for interference and diffraction means yes, law of conservation of energy is valid for interference and diffraction. What is interference? Getting maximum intensity and minimum intensity alternately. At the case of maximum intensity is high. At the minimum intensity is low or zero. So here energy is redistributed. Energy is redistributed. Energy is not lost anywhere. Completely lost, completely gained, not be there. So energy is redistributed. Though principle of conservation of energy is valid, at maximum intensity it is gaining, at minimum intensity it is losing, but total energy will remain constant. In case of diffraction also like that. In case of diffraction, minimum intensity will remain same, maximum intensity will decrease. But even then, redistribution of energy takes place in case of diffraction. Principle of conservation of energy is valid for both interference and diffraction. What is principle of conservation of energy? Total energy should remain constant. That is valid. You are right first. Total energy should remain constant. In case of interference, we will get bright fringe and dark fringe, bright band, dark band alternately. So in bright phase, intensity is maximum, and in dark, intensity is lost. But total energy will remain constant. Like that, you have to explain. Energy is redistributed. Next question. In wave optics, principle of conservation of energy, I told, interference, diffraction, Doppler effect also I told. One more, I'm thinking resolving power of phi they are asked. Resolving power of phi. For that diagram is there, your patch of bands you take. One is black strips, another is separated by two black strips separated by white strip. You paste it on wall. Initially black strips and Initially, black strips are narrowly placed, but we are going from left to right. Last black strips, between that white strip is gap is very much high. White strip gap is more. So you can see with your eye that band of black strips and white strips as you're going from left to right, moving away and toward the wall. That is the resolving power of eye. That also you practice. Next chapter, I'm telling about moving charges and magnetism. Moving charges and magnetism. Moving charges and magnetism. State and explain Biot-Savart law. State and explain Biot-Savart law. State and explain Biot-Savart law. I am writing briefly now. Briefly, by extend Biot-Savart law, what is dB is nothing but equal to, what is the formula? dB is proportional to small magnetic field is proportional to I dl proportional to sin theta proportional to 1 by r square. So there is a wire like this. You will take element, the current dl element and point P, distance r. This angle is theta. So dB is, so what is the formula now? Ultimately dB is nothing but constant mu0 by 4 pi ideal sin theta by r square. This is Biot-Savart law. This is called Biot-Savart law. dB is called small magnetic field, I is called current, dl is called current element, theta is angle between ideal and r. At the point P, we want to calculate magnetic field. At this point, we want to calculate magnetic field at this point. So this is the formula. What is mu0? Permeability of air. This is one question. Ampere's law also they are asking, but please study the book. I am writing only statement here. Ampere's law. What is Ampere's law? Integral B dot dl is nothing but mu0 times the current enclosed. This is called Ampere's law. Magnetic moment of revolving electron. I am doing one small question. Magnetic moment of revolving electron. Revolving electron. This derivation they are asking. Magnetic moment of revolving electron. They are asking derivation. What is the derivation? In an orbit of radius r, electron is revolving with a velocity v here. Magnetic moment is given by the formula current into area. Current into area. I is called current area. What is the area of circle here? Pi r square. Current into area, pi r square. So current, how to find out? How to find current? Current is nothing but charge by time period. This comes from current electricity. Current electricity, I is charged by time period. Time period again given by the formula time period, one revolution, circumference 2 pi r, speed is v. So you are getting current value as EV by 2 pi r. EV by 2 pi r. This is the value of current. Substitute in second equation. This is third equation. This is fourth equation. Substitute in the magnetic moment equation. Magnetic moment equation. We are going to get I means what? EV by 2 pi r. Area means what? Pi r square. Pi gets cancelled. R gets cancelled. We are going to get answer EVR by 2. EVR by 2. E means charge, V means velocity, R means radius. Okay, students. This is also very, very important. I am telling current into area, current into pi r square, circle, orbit E by time period. Time period is given by 2 pi r by V. I is equal to EV by 2 pi r. Instead of current, EV by 2 pi r into pi r square. So magnetic moment of revolving electron is EVR by 2. EVR by 2. Next, electromagnetic induction. Electromagnetic induction. Electromagnetic induction. Electromagnetic induction, they are asking, what is the important question? Electromagnetic induction, they are asking, important thing is, electromagnetic induction, they are asking, important question is, they are asking this one. What is that? Electromagnetic induction, They are asking applications of eddy currents, applications of eddy currents, application of eddy currents, applications of what are eddy currents? Eddy currents are induced currents in what are eddy currents? Eddy currents are induced current generated in metals. What are eddy currents? Induced currents generated in metals. What is the use of eddy currents? One use is so magnetic damping. Magnetic damping. Second, magnetic braking. Braking of magnetic braking. To apply brakes, you are using induced currents. It will apply the brakes like friction. It will act like a magnetic damping. Whenever pendulum oscillates due to induced currents, amplitude dies. Each one sentence you have to write. If you write only headings, you will get only 2 marks. Induction furnace. You are using induction furnace. Uses induction furnace. Induction furnace. Now we are using another thing is power meters. Power meters. So these are the headings. Uses of eddy currents are the induced current generated in metals. It is used in magnetic damping to reduce the amplitude of the pendulum. Magnetic braking in railway tracks, due to this changing magnetic field, induced currents are provided that will make the train to come to rest in other countries, foreign countries. Induction furnace, this technique is used to heat. The induction furnace use heat. That is used. Power meters, shiny disc is there in power meters. That is used in induced currents is used. This is a very important question. Another question is magnetic energy stored. Magnetic energy stored, they are asking magnetic energy stored. I am unable to explain. I will now keep headings only. Time is getting up for me. Magnetic energy stored. Magnetic energy stored. U is nothing but half Li square. U is nothing but half Li square. L is self-inductance, I is current. L is self-inductance, I is the current. Magnetic energy derivation. Magnetic energy derivation they are asking. Magnetic energy derivation. Magnetic energy density also they are asking. L is called inductance. This is derivation based practice. Next question, I forgot to one chapter called charges and fields. If not, charges and fields, potential and capacity. What are the important questions I will tell you? Charges and fields. That is one question is state and explain Gauss law. 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 One question is state and explain Gauss law. What is Gauss law? Flux is nothing but charge enclosed, total charge by epsilon naught. This is flux, Gauss law. Gauss law is also known as integral E dot ds. Integral E dot ds is equal to Q by epsilon naught. What is importance? Gauss law is used only for closed surfaces. Gauss law is used only closed surfaces. And closed surface can be any shape. Gauss law is valid for closed surfaces. Q1, Q2, minus Q3, outside surface won't take. Only closed surface. Closed surface can be any shape. It can be of any shape. To calculate electric fields, you will use Gauss law. It is one question. Another question is electric field on axial line. Electric field on axial line of dipole. On axial line of dipole. They are asking this derivation in practice. Electric field in axial line. What is the formula? 1 by 4 pi epsilon naught, 2p by rq. Practice derivation. Practice this derivation. I don't have time because only we are having 2 hours. I discussed very short questions that are long. But I discussed some short questions appropriately. And potential and capacitors. Potential and capacitors. I forgot to tell about this. Potential and capacitor. Capacitor. What are the important questions? Parallel. Derive the expression for capacitance of a parallel plate capacitor, parallel plate capacitor, parallel plate capacitor. This is very important. They are asking, very important, very important. Parallel plate capacitor, there is a two plates here. One is plus charge, another is minus charge. A is area of the plates, D is distance between the plates. There is a uniform electric field is there here. So this is the parallel plate capacitor, this is the parallel plate capacitor. Capacitance is C, A is area, D is distance between the plates, area of each plate. How to derive? Electric field between the plates, E is electric field. This is electric field, is given by sigma by epsilon naught. Between the two plates, sigma means surface charge density, that is given by the formula Q by A into epsilon naught. Electric field, sigma by epsilon naught, Q by A epsilon. Sigma means charge density, Q by A epsilon naught. Potential difference, let V is the potential difference. V means E into D, potential difference. V is equal to E into D here. Then basically capacitance. So potential difference how to calculate? E means Q by A epsilon naught permitted. This is potential difference. By definition, capacitance is given by charge by potential difference. Charge by potential difference means QD by epsilon naught E. So QQ gets cancelled, capacitance will get epsilon naught A by D. This is the derivation for capacitance of parallel plate capacitor, parallel plate capacitor. Okay, students, parallel plate capacitor. Now, potential due to a point charge at a distance. Potential due to a point charge at a distance. Point charge at a distance R. This is derivation. You learn. Very rarely come derivation. Please learn derivation. What is the formula you should get? V is equal to 1 by 4 pi epsilon naught Q by R. Q by R. Another thing is capacitance in series. Capacitance series derivation. 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C. Derivation. You learn this derivation. Behavior of dielectrics. Behavior of dielectrics in the electric field. Last, if you can study, otherwise you leave. Behavior of dielectrics. What are dielectrics? In the electric field. Dielectrics in electric field. Electric field. These are the questions. Electrostatics, charge and field, potential and capacitors. Lastly, we are telling about semiconductors. Semiconductors. So what are the chapters we mentioned? Ray optics, wave optics, charge and fields, potential and capacitors, moving charge and magnetism, electromagnetic induction. Then atoms. Atoms is also there. I will write one side atoms. Atoms, one third term, semiconductors. Atoms and semiconductors. Atoms and semiconductors. So atoms, what question will come? There are two very important questions. Bohr's theory drawbacks. Bohr's theory drawbacks they are asking. Bohr's theory drawbacks. Bohr's theory drawbacks. What are Bohr's theory drawbacks? So it can explain about frequencies of spectral lines, but cannot explain intensity of spectral lines. Intensity of different spectral lines are different. Intensity of, even though in Lyman series, for example, we are having an ultraviolet region, same frequency, but different lines. Let us maximum first line, shortest wavelength, n2 is equal to infinity. So different series, different frequencies are having different intensities. That is not been explained by Bohr. Bohr says that they are revolving in circular orbits, but it says that finally it is revolving in elliptical orbit, but not circular orbits. So there are some drawbacks of Bohr's theory is there. Drawbacks, that is Bohr's theory. The second one is explain spectral series. That is in chemistry you are learning. Explain spectral series. Spectral series. That is one Lyman series. We are having Lyman, then Balmer, Gaussian, etc. Bracket, and then fund, P silent, fund series. You have tried the formula 1 by lambda is equal to R into 1 by N1 square minus 1 by N2 square. Lyman series lies in ultraviolet region, Balmer series lies in visible region, Paschen series lies in near infrared region, Brackett series lies in middle infrared region, Fund series lies in far infrared region. You have tried the formula 1 by lambda is equal to R into 1 by N1 square minus 1 by N2 square. So N1 is 1 for Lyman series, N1 is 2 for Balmer series, N1 is 3 for Paschen series, N1 is 4 for Brackett series, N1 is 5 for Fund series. Semiconductors, what are the main things, sir? One is half-wave rectifier. One is half-wave rectifier. One is half-wave. Earlier I explained, 15 days back, 20 days back, I gave lecture. At that time, I told, I think, half-wave rectifier, one diode is used, full-wave rectifier, differences, distinguish half-wave rectifier and full-wave rectifier. Explain NAND and NOR gates. These 4 questions if we read, in this question is very easy. Distinguish half-wave rectifier, one diode is used, full-wave rectifier, 2 diodes are used. Efficiency is half-wave rectifier 40.6%, in full-wave rectifier efficiency is 81.6%. Sorry, 81.2%. Half-wave rectifier 40.6%. This is 81.2%. Here one diode is used, 2 diodes are used. So in output you are getting discontinuity. In half-wave rectifier. Like that. NAND and NOR gates, NAND and NOR gates, truth tables, AND plus NOT, that is very easy, but they are asking this also very nicely. But they have to explain half-wave rectifier, you have to take diagram, student. You have to take diagram, because I have to explain still to you long questions. So long questions, what are the list I have given you? LEAQs now. LEAQs. Finally, LEAQs when you are taking. Finally, LEAQs. LEAQs are coming from the chapter waves. Second is current electricity. Third, nuclei. In these 3 chapters, long questions are coming. What are the questions are coming? At least 2 questions I'll explain today. Again, I'll just revise. Waves, there are 4 long questions are there. Current electricity, there are 2 important long questions are there. Nuclei, again, 2 important long questions are there. What are they? We are doing. What are they? We are doing waves. What are the long questions? One is open pipes. I'm not writing complete question. Open pipes. We are having discuss mode of vibration in open pipes. Discuss the mode of vibration in open pipes. Mode of vibration in open pipes. Open pipe means open at both ends. What is open? Open. In this waveform will be like this. Fundamental frequency I am explaining. Here antinode is formed. Node. What type of waves are formed? Longitudinal stationary waves are formed. What is the fundamental frequency here? V by 2L. Based on this, they are asking problem. Problem, what is the problem? I am discussing long question problem. L is 85 centimeters. Velocity of sound 340 meter per second. Calculate the fundamental frequency. This is called fundamental frequency. N1 is nothing but equal to 340. 85 centimeters means 0.85 meters. 2 into 0.85 meters. Thereafter, you have to calculate 340, 2 zeros, adding 2 into 85. 34000, 2 into 85 is 170. 0, 0 gets cancelled, 17 goes 2 times 200 hertz. We are getting frequency nothing but 200 hertz. Okay, so the open pipes problem. Second, closed pipes. I'm telling about closed pipes. Closed pipes derivation is there. What is one end is closed, that is called closed pipe. So in this waveform will come, initial frequency will come like this. Here antinode is formed, here node is formed. What is the fundamental frequency? V by 4L. L is 70 centimeters. Once again, velocity is nothing but 330 meter, 340 meter per second. What is the fundamental frequency they ask? So fundamental frequency I'm doing here, I'm writing here, fundamental frequency. N1, V 340, you have convert 70 meters to 4L, right? 340 into 4 into 70 centimeters. 70 centimeters means 0.7 meters. So convert into meters. 0.7 meters. 0.7 meters. You calculate this, you are going to find out the fundamental frequency in closed pipes. Closed pipes. Remaining derivation you can do. Today, what I did is for you, students, for you, what I did is problem. Because waves, they are not asking completely for 8 marks, 6 marks. Derivation they are asking. Derivation you can do easily. Derivation you can do easily. So open pipes, fundamental frequency, first harmonic, second harmonic, third harmonic. Here having first harmonic, third harmonic, fifth harmonic, like this. Doppler effect is another thing. Doppler effect is another thing. Doppler effect in sound, when source is in motion, observer is at rest, you are having. So what is the apparent frequency? Doppler effect is also important. Doppler effect in sound. Doppler effect in sound. So they are asking problem also in this here. Doppler effect in sound. Apparent frequency N dash is nothing but V plus or minus V naught by V minus or plus Vs. What is V? Velocity of sound. What is V naught? Velocity of observer. What is Vs? Velocity of the source. In this problem which is moving, let us say observer is one train. This is another thing source. Another train. They are approaching each other. What formula you write? N dash is equal to train, observer, this is V naught, this is Vs. V plus V naught by V minus Vs. When a source is approaching, minus you will write. Observer approaching plus. You write you take the values V naught and Vs, they will give in kilometers per hour, convert into meter per second, velocity of sound you take. So this derivation, what is the derivation they are asking? Derivation procedure you know. So derivation is like this, there is a length L is there, source is in rest now, source is moving like this, with a velocity Vs like this. So we are doing derivation, Doppler effect. So I am unable to explain all the derivations now. So there is no use of my telling derivation. In regular classes we tell derivations. Let us say long questions, 3 hours class is there. Then we can tell all the derivations. Now 2 hours I have to complete. Mainly very short questions will suffer. I explained. Short questions, some of them I explained to you, important questions. Of course, 50% I explained, 50% you have read. I'm telling what questions will come. This is waves. Then current electricity. Current electricity, what questions will come? Current electricity. Current electricity, what questions are coming? Of course, Kirchhoff's laws, Wheatstone's bridge. Kirchhoff's laws and Wheatstone's bridge. Wheatstone bridge. 70% they are asking this only. Wheatstone's bridge. You know, in this one problem is asked. One problem is asked. A wire of resistance. What is the problem? You know, Wheatstone's bridge, how to do it? Kirchhoff's laws, you know, first law, second law. First law, algebraic sum of the currents at a junction is 0. What is Kirchhoff's first law? Algebraic sum of the currents at a junction is 0. Sum of the currents entering the junction is equal to sum of the currents leaving the junction. What is second law? Algebraic sum of the potential drops around a closed circuit is 0. Sigma E1 plus I small r I into minus I capital R is equal to 0. Like that, but apply the second law. E stands for EMF. IR stands for potential drops. Like that. So Kirchhoff's law should explain Wheatstone's bridge. You know about Wheatstone's bridge, how it looks like this. Wheatstone's bridge is there, here one resistance 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 is there, here galvanometer is there. between batteries there. We have P, Q, Rs, or R1, R2, R3. When Ig is 0, P by Q is equal to R by S. This is balanced bridge condition. Balanced bridge condition, Ig should be equal to 0 here. Here current comes and splits here. Current comes and splits here, I1 as I2, Ig becomes 0. See, this is nothing but I1 minus Ig. This is nothing but I2 plus Ig. Like this. So there are many ways of doing derivation. Whatever way you are remembering, whatever book you are, the textbook you are reading or any other guides you are reading, practice 2-3 times and remember the way. Here one problem is asked. I'm doing problem. A wire of resistance 4R is bent in the form of circle. 4R is bent in form of circle. In form of a circle. What is the resistance? What is the resistance between the extremities and diameter? What is the resistance between the extremities of diameter? Between the extremities of diameter. A wire of resistance 4R. A wire is having resistance 4R. It is bent in the form of circle. Like this. This is one resistance. This is another resistance. This is called diameter. This resistance is 2R. This resistance is 2R because 4R is bent into two parts. One part is this, another part is this. 4R is bent into two equal parts. One is 2R, another is 2R. Between A and B, they are in parallel. How to find resistance B? They are in parallel. 1 by resistance in A, they are in parallel. 1 by 2R plus 1 by 2R. It will become LCM is 2R. 1 plus 1, 2 by 2R. Therefore, resistance of AB will become equal to R. Resistance of AB will become equal to R. This is the important problem they are asking under Wheatson's bridge. Another question is potentiometer. This is very rarely 30% they are asking potentiometer. It is, what is the principle? Potentiometer, what they are asking? Principle comparison of EMF of cells. Comparison of EMF of cells are they are asking internal resistance of a cell. Internal resistance of a cell. How to determine. So, principle of potentiometer means potential gradient is proportional to length. This is called principle. Principle is what? What is the principle? Potential gradient is proportional to length. 5 minutes. Potential gradient is proportional to length. Potential gradient is proportional. Potential gradient is proportional to length. Okay, so this is potentiometer. You read yourself. Lastly, I'm telling you about nuclei. Nuclei, most important question is nuclear reactor. This is very important, very important. 70% chance is there for this. Second is radioactivity. Radioactivity. They are asking 65% to 70%. They are asking this. 35% to 30%. They are asking this question. Radioactivity. In radioactivity, you will write minus dN by dt is proportional number of atoms present at that, and due to integration and all that, we are going to get, after doing integration, n is equal to m0 e to the power of minus lambda t. Lambda is called decay constant. These are the questions. Nuclear reactor, what are the parts? Fuel, moderator, control rods, coolants, protective shielding. What are the nuclear reactor principle? Control chain reaction. Nuclear reactor principle is what? Control chain reaction. Parts: fuel, moderator, control rods, protective shielding, coolants. So that is important. You have to explain each and every part. What for moderator is there, what for control rods is there, what is the fuel, uranium fuel you are taking, what for coolants are used, how nuclear energy is converted to electric energy. That you are trying in working. Radioactivity, rate of disintegration proportion number of atoms at that time. So this is also important derivation. So you are doing. In this also they are asking problem number of fissions per second nuclear reactor. They're asking you to go through the problems, only two problems. Backside, you see any other material, you will get it. Students, don't worry, tomorrow's examination, whatever we discuss, whatever you prepare, definitely you will get. But those who want 60 out of 60, elaborately from textbook, to read, and all the questions. So, all the questions in the sense, blueprint only, you follow strictly blueprint only. Mainly theory you read, small problem, wherever necessary problems, you leave it. Short questions, you have to answer only 6 out of 8. Long questions also 2 out of 3 or 2. One choice is there. Out of 3, 2 only you have to answer. One waves question, another is electricity question, another is nuclei question. These 3 questions will come. You can answer any 2. Any 2. So in the waves also, there are 4 questions are there. One is strings. I didn't tell today. Strings, waves in stationary waves in strings, open pipes, closed pipes. Often they are asking open pipes, closed pipes, and Doppler effect derivation. They are asking this. Okay. Current electricity, Beats and Kirchhoff's laws only, mainly they are asking. Potentiometer is very, very rare. That's why you can take choice and do one well. Short questions, I told you different chapters how they are distributing. All the best, prepare very well. All the best for you, all the students, very best. First you attempt long questions, then you attempt short questions. Or short questions first, then long questions. Lastly, half an hour, you give 35 minutes or 35 minutes or 40 minutes. 40 minutes for very short questions, because at least 40 minutes you are due. 10 questions, 10 into 2, 20 marks are there. Out of 60 marks, 10 into 20, 20 marks. 1/3 of the paper is very short questions. If you do very well, definitely 60 out of 60 you will get. All the best, students from the institution Spark Academy. I am telling personally, Srinivasan, and you have to do very well tomorrow examination, and do very well. All the best for you. Thank you. Well.